This lesson is about the properties of equality. This is the first in a series of lessons that we'll do about properties of arithmetic. What properties means in math is it's like the rules, the things that we know are true about how math works. And at first, when you see these properties, they're going to look really straightforward and simple. And it's true that they are. As the math we do gets more complicated, sometimes it's easy to forget these simple properties and the things that they let us do. So we're going to spend a little bit of time understanding these properties in detail. Please make sure that you're working to take good notes to help you remember this important material. First, we need to understand what the equal sign in a math expression really means. What it means is that the two sides of the equation are equivalent. That means they are the same value. The first picture shown here shows one hand with a quarter and another with 2 dimes and a nickel. Even though the number of coins is different, in this case, the value of the money in the left hand and the right hand is the same. And so we can put an equal sign in between them. Typically in math, we're going to work with expressions like 6 plus 2 equals 8. It simply means that the expression on the left, 6 plus 2, has the same value as the one on the right, 8. Another really helpful way to think of this is that the two things on the side of the equal sign balance each other out. If I were to put them on a scale that measured their values, the two would be equal to each other. We're going to start by looking at some properties of equality. And again, these are the simple ideas that are going to become really important. So these are properties that hold true. These are like rules of math that hold true when we have an equal sign. The first is called the reflexive property. Think of the word reflection. A reflection, when you look in the mirror, the picture that stares back at you is the same as your own image. The reflexive property of equality says that a number is equal to itself. In this case, and in all of the examples I'm going to do, A simply stands for any number at all. A can be a whole number, a negative number, a positive number, an integer, a rational number. It can be any kind of number at all. And the truth of equality is that a number is always equal to itself. Now, you may look at this and say, duh, and that's fine. Your common sense tells you that this property is true. Some specific examples: 6 is equal to 6, pi is equal to pi, 8/3 is equal to 8/3. A number is always equal to itself. Next, we're going to look at the symmetric property of equality. Symmetry means two sides are the same shape but in opposite directions as each other. You may have worked in previous years in math with drawing lines of symmetry through shapes. You draw a line down the middle so that one side is the mirror image of the other. The symmetric property of equality essentially says that the equal sign works in both directions. If some number, A, is equal to some other number, B, then B is also equal to A. It just says that we can take an expression with an equal sign in the middle and we can turn it around, and it's still true. Some examples: if x equals 6, then 6 also has to equal x. If 2 plus 3 is equal to 5, then 5 is equal to 2 plus 3. Again, the symmetric property just says we can take an equation and we can flip it around the equal sign, and what we get is a new equation that is also true. Next is the transitive property of equality. This is where it starts to get a little bit harder. If A equals B, some first number is equal to a second number. And B, that second number, is equal to C, a third number. Then it must be that the first and third numbers are equal to each other, that A equals C. Another way of saying this is that if two quantities are equal to the same thing, in the example above, both A and C are equal to B, then those two things, A and C, must be equal to each other. This is a property where an example in the real world might help a little bit. Imagine we have 3 people. If John is the same height as Sally, so you picture the two of them standing next to each other, and Sally is the same height as Alice, then John must also be the same height as Alice. In math, here are some examples. If 2 plus 3 is equal to 5, and 5 is also equal to 6 minus 1, that says the two expressions, 2 plus 3 and 6 minus 1, must be equal to each other, because they're both equal to 5. We can use this whether we have numbers or variables. So for example, if x equals y, that says that two variables, x and y, have to have the same value, and we know that y is equal to 4, it must also be that x equals 4, even though nobody has told us that. It's something that we can infer using this transitive property of equality. Next is the addition property of equality. This says that if you start out with two quantities that are the same as each other, A and B, you can add the same thing to A as you do to B, and the results are still equal. So if A starts out being equal to B, I can add some other number, C, to both sides of this equation, and the equation is still true. A real-world example, again using the heights of our friends John and Sally. If John is the same height as Sally to start out with, and each of them grows 5 inches, they'll still be the same height as each other. They each add 5 inches to their height, and since they started out the same height, they end up the same height as each other. They're both 5 inches taller, but John and Sally are still the same height as each other. Some math examples. We start out with an equation like 2 plus 3 equals 5. And we notice that we can add 1 to both sides of this equation. 2 plus 3 plus 1 equals 5 plus 1. If we were to do the arithmetic in that example, we'd see that we just have the expression 6 equals 6, which is true. If we know that some variable x is equal to 2, then x plus 3 must be the same thing as 2 plus 3. If we were to simplify the right-hand side of that, we'd get x plus 3 equals 5. There is also a subtraction property of equality, and that just says that if two quantities start out the same, if A equals B, then we can subtract the same thing from each side, and the results will still be equal. Again, if John is the same height as Sally and they each shrink 5 inches, they're still the same height as each other. The math examples shown here are the same ones as on the previous page, only instead of adding the same thing to both sides, we're subtracting the same thing from both sides. I showed you the addition and subtraction properties of equality as being two totally different properties. Here's what I'd like your opinion on. Do you think that these two should be described as separate properties, or are they really the same thing, kind of masquerading? I'd like you to attempt to explain your answer in writing. That means use some words, and include a math example to support your answer. The goal of this exercise is to start us out with practicing writing about our thinking in math. So don't worry if you're feeling a little bit puzzled. All I want you to try and do is to get whatever thoughts you have on this question down on paper. It says in the directions to include a math example to support your answer. That means show a math problem with actual numbers and or variables that helps make your case, that helps show somebody what you're trying to explain in your words. Please pause this presentation while you do that writing. When you're done, you can resume your notes. Okay, next we're looking at the multiplication property of equality. This says that if two quantities are equal to each other, A and B are equal to each other, you can multiply them both by the same thing and the results are still equal to each other. So I can multiply A by some number C and B by some number C, and the results will still be equal. Again, using John and Sally with their heights, if John is the same height as Sally and they both double in height, that is, multiply their heights by 2, they're still as tall as each other. They're still the same height as each other. They're both twice as tall as they used to be, but their heights are still equivalent to each other. A math example, we know that 2 plus 3 equals 5, and if I multiply the left side of my equation by 2 and the right side of my equation by 2, I'll get the quantity 2 plus 3 times 2. That's I take the sum of 2 and 3 and double it, is equal to 5 times 2. If x, some variable, starts out equal to 2 and I double it, I get 2x, and I double 2, I get 2 times 2. I can multiply both sides of an equation by the same thing, and the results are still equal to each other. Here's another opportunity to do a little bit of writing on your own. I showed you a multiplication property of equality that said it's okay to multiply both sides of an equation by the same thing. Do you think there is a division property of equality? If you're the mathematician who's coming up with these properties of equality, would there be a division property of equality, and what would it say? Again, explain your answer in writing and include a math problem. Show some actual math work to support whatever answer you choose. When you're done with that writing, please pause. Please pause before you start that writing, and when you're done, you can resume this presentation. So a reasonable question to ask is, so what? Like, why are we bothering to learn these properties that seem to have this element of duh to them? We know this. Well, to help you understand why we're learning these properties, let's remind ourselves of some work you did last year. If I gave you this equation, x plus 4 equals 6, and I asked you, what does x have to be to make this equation true? And I told you you had to show all of your work. The first thing you might do is to subtract 4 from both sides of this. And then you get the expression that says x plus 0, because positive 4 and negative 4 add up to 0, equals 2, because 6 minus 4 is 2, and therefore x has to be 2. When you were doing that, look, you were applying the very first step, you applied the subtraction property of equality. That's the property that says if two things are equal to each other, if x plus 4 and 6 are equal to each other, if you subtract the same thing from both sides, in this case take 4 away from both sides, the resulting equation, in this case x equals 2, is still true. And x equals 2 is a useful bit of information because that tells you what x has to be to solve this equation. What about some other work that you've done in the past? If you had an equation like this, 2x minus 3 equals 3, the first thing you might do is add 3 to both sides. And you would get 2x plus 0 equals 6. When you do that first step, what you're applying is the addition property of equality. That adding 3 to both sides and not making the resulting equation be untrue, that's the addition property of equality. The next thing you might do then, now you have 2x equals 6, is go back and divide both sides of that by 2. That's the division property of equality that says if you have an equation, you can divide both sides by the same number. And the result that you get, in this case x equals 3, is also true. So the steps that you've been doing in the last couple of years have relied really heavily on these properties of equality. They're important to solving equations, and that's why we bother learning them. This is the end of this lesson. If you have questions or things that are unclear, a good idea to do is at the very end of your notes to put a little note to yourself that says, ask Mrs. Dever for help in class about, and then a note about whatever you're confused about.